Hello everyone, welcome back to my channel. And today we are going to continue with solving questions about finding the eigenvalues and eigenvectors. So if you don't know how to calculate eigenvalues or eigenvectors, you can watch my previous video. I have linked it in the description below. But in last lecture we studied about how to calculate eigenvalues and eigenvectors if the eigenvalues are distinct. That means, for example, 2, 3, minus 5, that is, they are not repeated. So, if the eigenvalues are not repeated, we find the eigenvectors by Cramer's rule. But today we are going to see how to calculate eigenvectors if the eigenvalues are repeated. Like if we get eigenvalues as 2, 3 and 2. So how to calculate the eigenvectors? So the method will be different. We will not be using Cramer's rule here. We will be using row operations. So for that, first you need to understand what is upper triangular or lower triangular matrix. So this you might have studied in previous semesters. So let me take an example. Let's consider a 3 by 3 matrix and we'll take the values 1, 3, minus 2, 5 and let's suppose 6, 4. So this I have given, this is an upper triangular matrix. So how to identify that? So you can see here that upper triangular will consist all of the elements or values in the upper part and the lower part will remain 0. So this is known as a upper triangular matrix. So now let's take up example of a lower triangular matrix. So let us 3 minus 2 1. Six, 5, 4. So this is an example of a lower triangular matrix because all the elements are in the lower half of the matrix and the zeros are in the upper half. So this is known as a lower triangular matrix. So if you understood this, let us start with solving questions where the eigenvalues will be repeated. So the question is, find eigenvalues and eigenvectors of the following matrix. And the matrix is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So this is a 3 by 3 matrix A and we need to find the eigenvalues and eigenvectors of this matrix. So first, to find out the eigenvalues, we will use the equation A minus lambda I. So substituting the matrix A and lambda I in last lecture I told you it will be lambda 0 0 0 lambda 0 and 0 0 lambda. So we will combine both the equations and we will get minus 2, 2 minus 3, 2, 1 minus 6, minus 1, minus 2, 0, minus lambda I, that is lambda 0 0 0 lambda 0 0 0 lambda. So finally we get A minus lambda I as minus 2 minus lambda, this will remain as it is, 2 1 minus lambda, this will be minus lambda. So now to find out the eigenvalues, we will consider characteristic equation, which is what a minus lambda I modulus is equal to 0. So in last lecture I told you how to calculate the mod of this matrix by shortcut method. So if you don't know, then I will solve. So by using shortcut method we get the modulus as lambda cube minus trace will be minus 2 plus 1 plus 0, that would be minus 1. So this will become plus lambda square and my sum of minus of the diagonal elements. Let me write the formula below. The formula is lambda cube minus trace of lambda square plus sum of minus of diagonal elements into lambda and minus mod A. So we'll just continue our substitution. So the minus are minus 12, minus 3 and minus 6, and the determinant comes out to be 45. So now we'll solve this equation and we'll get the values of lambda by putting this equation into the calci. We get values as 5, minus 3 and minus 3. So here you can see that the eigenvalues are being repeated. So now we'll again make cases. So in the previous video, if 3 eigenvalues are there, then we made 3 cases. But in here, minus 3 and minus 3 are repeated twice. So in this, we will only consider 2 cases. So let's see how to calculate eigenvalues eigenvectors if the eigenvalues are repeated. So let's take first case as the repeated one, as we have done this distinct one in previous lectures. So we'll start with case 1 when lambda is equal to minus 3. So we will just substitute this lambda in our characteristic equation, that is this one. So by putting lambda we get the following matrix: 1 2 minus 3, 2 4 minus 6, minus 1 minus 2 3. And so we write the equation as a minus lambda I into x is equal to 0. So we will substitute this. A minus lambda I is this one, this matrix. So we will just write 1 2 minus 3, 2 4 minus 6, minus 1 minus 2 3, and x we can write it as x1, x2 and x3. Which is equal to 0. So now in previous lectures I told you I told you that after this you will solve by Cramer's rule. But now we are going to study how to solve if the eigenvalues are repeated. So if the eigenvalues are repeated, you just need to apply row operations. So by applying row operations, You will convert this matrix into a upper triangular matrix. So I will show you how to convert this matrix into a upper triangular matrix. So we just apply row operations. So to convert this matrix into upper triangular matrix, first step we need to do is to make this element as 1. And by making this element 1, we make these two elements as 0. Similarly, we'll apply row operations and make this as a upper triangular matrix. So we will try this. So in this matrix, our first element is already 1. So we will try to element the second and third column as 0 in these two columns. So we will apply row transformations as R2 minus 2R1. So this is R2 minus 2 times R1. And we will simultaneously apply R3 plus R1. So by applying these row transformations, we get the matrix as 1, 2 minus 3, and second and third row becomes 0. And we will keep x1, x2, x3 as it is, equal to 0, 0, 0. So you can see here that by applying row transformations, this matrix has been converted into a upper triangular matrix. So now we will just multiply this by this and we get the equation as x1 plus 2x2 minus 3x3 is equal to 0. So after this, we will just need to put any two variables as s or t. So in this, we'll start putting values from ending. So we'll put x2 as s and x3 as t. So if we put this x and t in this equation, so if we simplify the equation, we will get x1 plus 2s minus 3t is equal to 0. And from this we get x1 as minus 2s plus 3t. So our eigenvectors will be minus 2s plus 3t, and x2 is s, so we'll write this as s plus 0t, and our x3 is t, so we'll write 0s plus t. So you got this. We'll first convert this matrix into a upper triangular matrix, then we'll write its equation, then we'll substitute. So in this there are 3 by 3 matrix. So in this upper triangular matrix there are 3 variables and we have only one equation. So 3 minus 1, 2. So we'll put any two variables as s or t. So if we had 3 variables and 2 equations, so we will put 3 minus 2, 1 as s. So like that we will solve the equations. So we can simplify this x1 as we will separate both of this out. So this will give us minus 2, 1, 0, and taking s common plus 3, 0, 1, taking t common. So thus we get two eigenvectors. One is minus 2, 1, 0, and the other is 3, 0, 1. and no need to write this x1 in here because this will get eventually separated out, as you saw. So this is how we get two vectors by solving only one case. So the second eigenvalue is 5. So for case 2, when lambda is equal to 5, you will simply put this 5 in this equation a minus lambda I, which is given here, and then you will solve this by using our regular Cramer's rule, which I have explained it in the previous video. So you can do like that I'm not going to solve it here because we have previously done it. So this is it for eigenvalues and eigenvectors. So only this type of questions will be asked in the exam. First is when the eigenvalues are distinct, and second when they are repeated. So in next lecture I'm going to show you some properties on matrices, and then we'll move on to Cayley-Hamilton theorem. So that's it for this video. Thank you.